Hello engineers, welcome back to another video on low-level design. In this video, let's learn what is low-level design, why do we need to do low-level design, and what are the pros and cons of low-level design, right? So if you're ready, let's get started. So as you can see in this word, it's called low-level design. So if there is a low-level design, obviously there should be something called high-level design, right? So these are the software architectural design concepts, the low level design, the high level design that are used for planning a software or designing a software application. So to help understand low level design, let's first try to understand what is high level design. And then when we go deeper into the high level design, we will find low level design. So to understand high level design, let me make use of the concept called the C4 architecture. So C4 architecture is a commonly used practice in the software industry. I have used it multiple times in my career as well. So C4 architecture is a concept used by architects to demonstrate what a software is and what is the plan behind the software. So it has 4 levels mainly. One is the context. In the context level, we explain just what the application is about, who are the users, and what is the main goal of the application, right? So it is users and main goals. And then we go deeper into the context and we see containers. So this is where we define what is it that is required to build the software. Do we need a mobile app? Do we need a web app? Do we need a database? Do we need an external system and things like that? So these are the deployable pieces. All the deployable containers go into this level of the architecture. So at the first level, there is a context where we discuss why we are building this application and if there are any external systems attached to it. And we go one level deeper. We go into the containers and then we see what are the deployable stuff that we need. So each of the containers is a separate deployable. The mobile app that is going into the Play Store or the App Store. There is a web app that goes into maybe S3 bucket somewhere. And then there's a database server somewhere that is deployed and we make use of the database and things like that, right? Maybe there is an AI model running behind on some other Python server, right? All these are individual deployable pieces, and when combined together, it will give us our context and our system, right? And then when we go deeper into the container, we go into something called components. For example, when we go into one container, let's say we went into the backend container of some Python server, and then inside the container, we see some components, and each component may be defining something that is specific to that container, maybe an authentication system, maybe an AI model, maybe a REST API service or a GraphQL service, something like that. So individual components make up the container and each container will make up the context, right? So in components, we see individual features, you can say. So in components, we can see the individual features, the main features of the system. And then when we go into the individual feature, we see something called code. This is where we see our UML diagrams or sequence diagrams or whatever diagrammatical representation of the code that we can do to represent individual features or individual components, which will make up the containers, which will in turn make up the context, right? So this is the C4 architecture. And at the top 3 levels, we have the high level design. And here is where we have the low level design. So think of it like a space view. We go into the space, we come to our planet, we come to the country, we come to the city, and then we come to our house. So these are the multiple levels in software architecture that we can demonstrate to anybody. So if you're just demonstrating an architecture to a stakeholder, let's say, we will use the context. We will simply say what are the main goals and who are the main users. And then we are talking to a DevOps engineer, let's say. We are talking about containers. We are going to say this is where each container will go. Maybe one will go into AWS, another will go into Google Cloud and things like that. And when we are talking to, let's say, tech leads or senior architects who are responsible for maintaining and developing the code, we are talking to them in components. We are telling them these are the pieces in individual containers that we are going to build, and this is how they are going to communicate, maybe through REST APIs, maybe through message queues or brokers and things like that. And then at the low level, this is where we are talking to the engineers who will actually write the code. This is where we are telling them these are the classes we are going to use, these are the objects we're going to develop, this is the interaction between them, these are the sequence diagrams we're going to develop algorithms in, and things like that. So this is where low level design is. So do we need all of them for every software application? It depends. But without a plan, you may not be using C4 architecture, you may be using some other architecture design, but in some form, there should be a plan before starting the development. Otherwise, it will be like laying the bricks of the house, even without knowing how the house is going to look like, right? So that's the whole point of creating architectures and design documents, because they help us in understanding what the system is all about and how it's going to help us, right? So this is the high level design, and then this is the low level design. So let's take an example and see. So I have taken a simplified version of a Zomato system to help us understand how high level design looks like and how the low level design might look like, right? So I've taken simple examples just to make the concept of high level and low level design clear. Okay, so let's have a look. So this is the Zomato like system at a fairly simplified level. So we are at level 1. So this is the first C. This is the context. Okay, so in this context, we are building this piece, this food delivery platform, and it has mainly 3 users. One customer who is a hungry customer who wants to order food. And then we have the restaurant partner, restaurant that prepares and fulfills orders. And then we have the delivery partner, who is a delivery person who picks up and delivers food. So these are my 3 main users, and this is my system. And what is the goal of the system? It allows customers to order food from restaurants and have it delivered. Okay. And there are some external systems attached to this as well. There's a payment gateway, there's a map service, there's an SMS service and email service. So this is at a context level. This is something we use at the highest level to explain somebody what is the system all about. This is like an elevator pitch, you can say. And then we go deeper into the food delivery platform and see what are the containers inside this delivery platform. So we go into the next level, which is the container diagram. Okay, we are still in the high level design. We are at level 2, which is container diagram. So we are going inside the food delivery platform, if you can see this color. And then we have these containers. We have a mobile app, we have a restaurant portal, we have a driver app, and then we have a backend API gateway. And then we have some other backend services individually developed as microservices, payment service, delivery service, restaurant service, order service, and things like that. And then we have databases which are storing different stuff, and all these containers are communicating with each other internally to make the whole delivery platform system work, right? So this is at a container level. So these are the deployable pieces, individually deployable at different locations, right? And then we go deeper into one of the containers. So let's say we are going deeper into the order service container. And then we are looking at the third level, which is a component diagram for order service, right? Now inside order service, we have these components. We have the order controller, we have the order manager, we have the payment manager, and then we have the notification manager. So order controller is responsible for controlling the API. So this is an API service. It will control all the incoming requests and validates them. If it is okay, it will pass on to the manager layer. This is where the entire business logic takes place of order processing. Okay. And then we have the payment manager, which will handle payment processing. And then we have notifications. Okay. So all these are individual components that are required to fulfill the order service. And this is just one of the containers. And we went deep into one of the containers, right? And then we saw the individual components. We are at level 3 now. So far we are at high level design. And then when we go one level deeper, we will see low level design. So let's say we are going into order manager. This is where we see the low level design. This is low level design. This is where we see the UML diagrams. This is where we see the class. See, there's an order manager class, which is having 3 attributes. And then all these are the methods required to fulfill an order, let's say. Okay. And this is how the order object looks like. These are the individual attributes per order. And then we have calculate total and update status, right? And then we have the relationships as well. Every order will contain an order item, and every order has an order status. One of these will be the status, right? So this is what we look at when we talk about low level design. So I hope you got the picture of where low level design fits in the entire software architecture space, and how low level design is not something separate from high level design, but it is actually a part of high level design and the entire architecture, right? So is high level design required? Yes. Is low level design required? Yes. To what level? It's something, it depends on every application and the needs of the teams, right? But some form of LLD and HLD is required to build any kind of software application. Even if you're building a simple to-do app, right, you will make some plan on a piece of paper that I want to make a to-do list, and then I want to tick it off, and then I want to set up maybe reminders, I want to manage them in groups and things like that, right? So everything needs a plan, and that's why we need low level design and high level design. So we have covered what is high level design and what is low level design. If you have any other experience with high level and low level design, do put them in the comments so that I can learn, others can learn from your comment as well, right? And if you want to learn more about the high level design, I will put a beautiful video in the description below. Definitely check it out. It's a wonderful video. It will teach you everything you need to learn about the C4 architecture and how teams use to make amazing architecture designs using this architecture, right? Okay, now let's look at why we need low level design. So as I said before, the first need is to have a plan. Do not get into code without a plan. That is a given, right? And because we have a plan, everybody is on the same page. There are no assumptions. So we have discussed a plan as a team, and then we are implementing the plan as a team. There are no assumptions left, and it essentially avoids rework. Because we are going with a plan, everybody is kind of aligned to the plan, and then they are doing the work accordingly. So it kind of avoids reiteration and repetition of code. Plus, it improves code quality. Because while making these plans, we follow some best practices, right? And those are required to make the low level design and high level design possible. So because we are following some best practices, it automatically improves our code quality, and it gives us the kind of flexibility and scalability that we need in our code, because we want to make future ready applications, right? So these are some of the advantages of why we need low level design, right? Now let's talk about the pros and cons of LLD. So if I talk about pros, the first pro is it will give us a blueprint. So it will give us a blueprint of the code. So with this blueprint, we can share across teams, and we can share it with our clients as well if you're in the service space. And then everybody knows what is the code that is going to be built. And then another pro is, I already discussed, it will give us the code quality. Along with that, it will give us the scalability that we need. And it will give us the flexibility that we need. So these are some of the benefits. And what are the cons? Sometimes low level design discussions can take up a lot of time, depending on the complexity of the application and the time you have before developing. And then there is this concept of over engineering. Sometimes we can get lost into the design itself, that we kind of keep doing the design without ever actually writing any piece of code. So that's the kind of balance that we need to maintain, so that we are using the design as an artifact to build the software rather than as a documentation activity, right? So sometimes it can be overwhelming and we can get lost, but it's the balance that we need to maintain when doing low level design and high level design. Okay. So we have discussed why we need low level design, and we have discussed some of the pros and cons of low level design, right? So if you have any other pros and cons that you have in mind, do put them in the comments below so that everybody can see and share, right? So that's all I had for this video. I will quickly see you in the next video. Meanwhile, do drop a like if you found this helpful, and do leave a comment if you have any questions, and don't forget to subscribe if you haven't done already. Thank you so much for watching. I will see you in the next one. Cheers.